Alright, in this problem we're trying to find where the function f of x is discontinuous. So f is defined by sine of 1 over x minus 3 if x does not equal 3, or it's defined by 0 when x equals 3. So what we got to do to see if it's discontinuous somewhere, and it looks like the only place where it's maybe discontinuous would probably be at 3. For two reasons, and that's because the function is defined differently at x equals 3 than it is everywhere else, and it's defined everywhere else other than 3 by y equals sine of 1 over x minus 3. Now just normal sine of x, y equals plain old sine of x, that is continuous everywhere. So that one is continuous for all x. Now sine of 1 over x minus 3, that's a little bit more complex, but the inside part of the function 1 over x minus 3 is only discontinuous where its denominator is 0. So that one has a vertical asymptote, or is discontinuous at x equals not 0. I think I said that wrong. Where its denominator is 0, which is at x equals 3. So maybe this is discontinuous at 3, or maybe it's not. We'll have to see. But what we could do is find the limit as x approaches 3 of the function, and then see if the limit equals the y value. Now the y value at 3 is 0, and it does say state the points at which it's discontinuous, which kind of implies that it probably is discontinuous. But anyways, to find the limit as x approaches 3, well, since f is defined by sine of 1 over x minus 3 when x is close to 3, because it's defined by that everywhere except at 3, we would plug into that to find the y values. So that limit would be equal to the limit as x approaches 3 of sine of 1 over x minus 3. Now you could find that limit numerically if all you have is a scientific calculator, which would be what you would probably do on a test. So you would find it numerically by making a table of values, approaching 3 from the right and the left, or maybe you just have to do one side to figure it out. But if you do that, you're going to get some kind of erratic values. Now sine of anything is always between -1 and 1. So sine of 1 over x minus 3 is always between -1 and 1. But as x gets closer and closer to 3, this denominator gets smaller and smaller, so you're taking sine of larger and larger values, which is just putting you at random points out on the sine function between -1 and 1. Graphically, the graph of sine of 1 over x minus 3, you can see the function right there, looks like this, and it actually oscillates infinitely often right there at 3. So that limit is undefined because it just continues to oscillate more and more as you get closer and closer to 3. So actually the limit as x approaches 3 doesn't exist. So what type of discontinuity is it? I would say none of those. It's not a hole, it's not a jump, and it's not a vertical asymptote. It's an infinite discontinuity that oscillates infinitely often. And it is discontinuous also at x equals 3.